All right. So we should have some nice closed captioning going. Let's kick this off. My name is Lara Newsom. Oops. There we go. Already messing it up. I'm a software engineering technical leader on the customer experience team at Cisco. We work on a very large enterprise Angular application. So I've seen some stuff. I also am a host on the Angular Plus show. So if you are in the Angular community and you are not following the podcast, I recommend that you go ahead and do that selfishly and because I think we put out a great product. We have some amazing guests that are currently airing on season 4, including our wonderful host today, Adi. And then we have amazing lineups already scheduled for season 5. So you can subscribe wherever you listen to podcasts. And again, my Twitter handle is Lara Newsom. My DMs are open. You're welcome to reach out to me there. The talk I have for you today is called Stop Micromanaging Your State and Start Being Reactive. Now, this is a talk that is near and dear to my heart because there's a lot of micromanaged state out there in the Angular community. And I think that it's really important to recognize this as an anti-pattern and talk about what we can do to start making our code a little better. So I do want to say we are entering a shame-free zone. I am going to show some code on the screen, and some of you might think, hey, I wrote that code, or I work on code like this every day. And I'm not here to tell you your code is bad. I'm here to point out some of the problems I've had and I've personally run into with code that looks like this and offer some solutions for how to get around it. And I have personally written code like this, right? So it's just code, nothing to be ashamed of, right? So state micromanagement, the anti-pattern. So this is when state is imperatively declared and managed inside the component. So this is kind of a sort of a dense definition. So let's sort of break that down a little bit. What does that look like? So this is when you end up with components that have brittle and difficult to understand code. So you probably would know this code because anytime you get a bug ticket on certain components, you might think, oh boy, here we go, right? Like I'm just as likely to fix it as I am to break it again. So it's also code that's not easily scalable or shareable. So these are the components when your product team says, let's add a feature, and you think, oh, I got to put another thing in that component, right? And then these components are typically extra large, not hundreds of lines of code, usually thousands of lines of code. Although some 100 lines of code could also be considered micromanagement. So why do we code imperatively in the first place, right? Because this is a pattern I see all over in Angular. Well, it's imperative programming is how a lot of us were trained to write code in the first place. And even if we look at the Angular Tour of Heroes, they sort of encourage a more imperative style of programming, right? We're subscribing to our service directly in ng on init, and then we're going to use the data that we get back from those requests to set component properties. Now, there's nothing wrong with this code. It absolutely works until it doesn't, right? So let's look a little closer at the state micromanagement anti-pattern. So symptoms of the state micromanagement anti-pattern are redundant or unnecessary component properties. Now, if I was in a room, I'd ask you to raise your hand if you have components with hundreds of component properties or even dozens of component properties, right? They don't get smaller, they get larger and larger and larger, right? And these components typically have void methods that mutate state. So it'll be a void method, and then inside of it, it might call other void methods. It might mutate the component properties. And then we also see a lot of direct subscriptions inside the components. So let's dissect this first one, right? Imperatively declaring all state in component properties. So this tends to take has certain characteristics. So I'm going to break a few of these down. So we have the derived state properties. So this is a good example where we've got a count, right? Now, typically our count numbers are not coming directly from an API. Sometimes they are, right? Sometimes there's a valid count property. But typically it's something like this, where we've got an array and we're setting a count property to be equal to the length of the array. Now, that means that anytime the length of the array changes, you have to also adjust the count property. So derived state is disconnected from its source, which means it has to be manually managed. And I don't know about you, but I'm a human, and sometimes I forget to do stuff, right? So it's prone to bugs. Here's another flavor of the component properties: multiple arrays to track state changes, right? So here's a whole bunch: add IDs, selected IDs, edit, deleted IDs, exclude IDs, all of these, right? These two are very similar. I'm not sure what all of these are for. And when I open this component, I still don't know what all of these are for. And here they are in action, right? So I've subscribed and I'm going to set one of them equal to a copy of the response product IDs. And then I'm going to set one directly equal to the response product IDs. And then you can see we have our count property, which is the length, right? So all of these properties are going to have to be manually managed. So why is this an issue? Well, again, it's a manual process, and this quickly becomes tedious. When you've got 7 different arrays that you have to manage every time something changes, there's a really good possibility you're going to forget to do that, right? And that's how bugs get introduced to our code. So why do we track state in arrays in the first place? Well, it's usually to maintain a previous state, right? We're typically copying code so that we can mutate it. And it's an attempt to reduce data requests, right? So we want to keep track of the state that came from the API so that we know if we changed it. But in order to do that, we have to make copies of copies of copies, and it cascades from there. Then we have our redundant properties with confusing names. This is one of my favorites. Is all selected and is select all. What's the difference? I still can't tell you, right? So how do we end up with so many properties? Well, we're responding to different events, right? Typically you'll find a lot of Boolean properties, like did this happen? Is this the case? Is this true? We're trying to manually manage our state. And it also happens because of what I call property fatigue. So if I open a component and I can't tell what is select all does, I might go ahead and make another property called is all selected, right? Because I know what I need it to do, but I have no idea what these other properties are doing. So I end up making new properties so that I can follow my own thought process through the component, and I end up leaving the old ones in there because I'm not sure what they're doing, right? So this is how we end up in this situation. Now we've got problem number 2, which is the void methods that manage the state of all the many component properties. So why is this an issue? It's a manual process and it becomes tedious, but it's also really tightly coupled to the component. So if you've got void methods that are mutating state inside your component, you can't move them out of your component, right? So why do we use void methods? Well, it's because we have stateful properties, right? We have to be able to toggle the state of those properties somehow, and we have to be able to react to events. And frankly, it's the fast and dirty way to do it. So do you ever wonder how we end up with 3,000 line components? Some of you may remember select all from my talk at Conf 2022, right? This is one method that has 40 lines of code in it, right? All this thing is supposed to do is select all. And as you can see, we go through, I'll move my mouse around here. Here's our friend is select all, and then there's is all selected. What's the difference? I still don't know. It's going through resetting some of our array properties. It's for eaching over things, it's mutating, it's pushing, it's mapping, right? I'm not entirely clear what this is doing. And again, it's 40 lines of code. Try to test this thing. Good luck. So let's look at a method we might want to reuse in another component. So first of all, the problem we have here, we've got a regex string that is just hard-coded in here. So chances are this is a string that's going to be used in other places, but we can't share it like this. So I would pull that out into a const. This void method is it's mutating a whole bunch of component properties. So I'm not sure how I could possibly move this out of this component to share it with another component. It's calling another void method, right? So how do we share it? Well, we do copy pasta time, right? This is where we copy that component, we copy that function or that method, and then we're going to just paste it into another component, right? And this is how we end up with a code base full of duplicated code. So if you have a large enterprise app that you're working on that follows these coding patterns, chances are you're going to have the check valid name method on every single component because it's never been properly refactored out so that it can be reused. All right, problem number 3, direct subscriptions and response handling inside the component. So how does this happen? Well, it turns out when you manage all of your state and component properties, that incoming data has to be surfaced inside the component to be able to set the values for those component properties at all, right? So the risk with direct subscriptions are that we can run into memory leaks. So this is a very common problem with a subscription. We'll go into that a little more here. It's a very manual management of state. And then we also run the risk of ending up with nested subscriptions. So let's first talk about observables versus subscriptions. So observables themselves are lazy. They are not, they actually don't execute until you subscribe to them. The subscriptions are the resources that execute the observable. So what does this mean? Well, this means that subscriptions actually exist outside the context of your component. So once you subscribe inside your component, that subscription will continue to execute even after your component has destroyed. And so that means if you want to close out that subscription when your component is destroyed, you have to manually do that somehow. And so there are patterns for that. I do have a link to the slide deck I'll give you at the end, but there's a link here, right? So you can follow the take until pattern. This works. So basically, when this take until, the observable inside that take until emits a value, it will close out this subscription, right? So typically you'll put this destroyed you'll emit a value to the destroyed stream in ng on destroy, right? So that works, right? But the problem with this method specifically is that every time you invoke this method, every time you call build table, it's actually it's creating a brand new subscription. So if you use this build table often in your component, let's say you invoke it 7 times, you're going to end up with 7 subscriptions in memory. So if you've got a long-running component that has a method like this on it, even if you're properly managing those subscriptions on destroy, you're still spinning up new copies over and over and over again. So you can end up with many open subscriptions. Void methods also compound the issue by hiding nested subscriptions. So this is what I'm talking about. This is a hidden nested subscription. So we've got one method here. So get selected products for edit, and we're subscribing to that. And it manages a whole bunch of component properties. And then it calls another void method, right? So then we're going to go straight into that void method, all right? And you can see it's got a subscription block inside of it. So this is the first subscription, and then inside of that subscription, we're nesting another one. So what's so bad about that? Well, it can introduce race conditions, and these race conditions are guaranteed to only show up in production. They're going to be hard to replicate, and they're going to be hard to fix. And we also have to remember that every subscription is a new resource in memory, which means that every subscription has to be unsubscribed. Remember this guy? Right. So let's talk a little bit about this race condition. So when we have a nested subscription, so let's say that first subscription emits 2 values, right? So first it emits a kayak, and then it emits a raft. So the kayak is going to be used to subscribe to that next subscription. And then we're going to get another brand new subscription when the raft comes in. Well, there is nothing to guarantee that the kayak response is going to come in before the raft response comes in, right? So if something happens to that kayak response, if it gets delayed, if it errors, the raft response could come in, and then the kayak response could come in, right? So you could end up with mismatched data on your page. So let's see, now that we've talked about all the parts of the state management anti-pattern, let's see how it can devolve into code chaos. So we're going to go through one method. This is just one method. It gets invoked on init, all right? So we go in here, sets a whole bunch of component properties, and then we're going to call this get product grid data. And again, there's our nested subscription. Who likes race conditions, right? And then it invokes another void method. So I wonder what's in there. It looks pretty simple, right? It's like one line of code. Oh no, that's 65 lines of code in a single method, right? And it's all about managing the component properties, right? And if you get a bug on this page and you have to look at this and figure out exactly what's going wrong, you're going to need some coffee, right? All right, so here we have a little close-up view of that. So it's doing a lot of the data manipulation that we've talked about, that manual management. So that's just one flow through that component, right? So that component was almost 1,500 lines of code. That's a lot of code to have to get through just to figure out what's happening. So what can we actually do if we are already following this pattern? Well, we can try coding reactively. So there's I know it sounds simple, me saying, let's just try coding reactively. You can start to build in reactive principles and eliminate your cognitive load in your components by doing things simply like eliminating unnecessary component properties, right? If I open a 1500 line code of 1500 line component, the first thing I'm going to do is go hunting for dead code, right? Because usually those components have a lot of dead code in them. So you can start reducing your properties. You can try to write your methods so that they're no longer void methods that just mutate state. You can make them methods that actually take in state and return state, right? So those are some steps you can start to take. But let's see what happens if we try to code reactively just through one process. So the first step, and the most vitally important step, is to understand what the component actually does and what the component needs. When you've got a 3,000 line component or a 1,500 line component, it's really hard to tell what the original requirements for that component even were, right? And so really, if you can distill down what the component is supposed to be actually doing and actually what it needs, it makes your process a lot easier. So we're going to look at this component. It's a fairly simple one. It's got a table that displays a list of products, and we can filter those products by type. Okay, so what are the data needs? Well, we need products, right? And we need filter values, and we didn't know how to select a filter. But like, this is where you should hear that like screechy brake sound, right? Do we really need products, or does our component actually only care about filtered products? Because even unfiltered products are still technically filtered products. All right. So what's the difference, you might be asking? Well, products, the second that we take products into our component becomes obligated to manage the state of that product array. Whereas if all we ever bring into our component are the already filtered products, it's no longer the responsibility of that component. Same thing with filters. Do we need filters, or do we actually only care about the filter selection state? And the difference there is that once we pull the filters themselves into our component becomes responsible for managing the state of those filters. All right, so what we really need here are filtered products, filtered selection state, and the ability to let the rest of the app know that, hey, my filter changed, right? Because reactive programming is really something more along the lines of stuff is happening, your component knows how to listen to it, and when it sees something it needs, it's like, hey, I need that. And then if something happens in the component goes, hey, something happened. And then the rest of the app is responsible for listening to be like, oh, hey, I care about that. I know what to do now, right? So that's what reactive programming is really about. So first thing we're going to do after we determine what our component needs is set up some streams. So why observable streams? Angular is intrinsically linked to observable streams, and that is because subscribed streams continue to execute as long as they stay open. So this means that if new values are coming into the stream, our components can then react to those new values. So how do we get data into streams? Well, there's a couple of different strategies. We can do service with a subject. So that would be using RxJS, which is already built into Angular. We could import some sort of state management library to do some global state management like NGRX, Akita, NGXS, right? There's lots of different strategies, lots of different state management libraries out there. Or we could use something more local to the component like NGRX Component Store. If you have the opportunity to listen to Alex Akrushko talk about NGRX Component Store, he's got some great patterns defined to use that with your applications. So for the remainder of this talk, however, we're going to be following the service with a subject pattern. And that is because if you are in a company and you would like to start programming more like this, you don't need to get permission to import anything new into Angular. You can do this with what's already in Angular today, which would be the RxJS library. So first off, we need to talk about subjects. So there really are three main types of subjects you're going to run into in service with a subject pattern. That's subject, plain old subject, behavior subject, and replay subject. And there are subtle differences between them. So the plain old subject, it does not have an initial value. It does not replay values, but it can have multiple subscribers. So the reason we want it to have multiple subscribers is that we want it to be able to, we want other components to also be able to get the data out of it, right? So that's how we're going to be able to share our data between components in our application. It does not replay values. So what I mean by that is if you push a value into the stream, so let's say you're using it for a token service and you get your authentication token back and you're going to store it in that subject, right? But then your component subscribes. Well, your component at that point is not going to get that token because that event has already been emitted. So that's what it means when we say it does not replay values. And it also does not have an initial value. So that means that until anything is in that stream, there is nothing in the stream. Now, behavior subjects require an initial value. So this is good. We're actually going to use this in our service with a subject, and I'll go into why in a little bit. But basically, you can set an initial value, and it would also cache the last value. So this would be if you wanted to make sure that any late subscribers will still get whatever that last emitted value was, you want to be looking at something like a behavior subject or also a replay subject. And again, like the regular subject, it can have multiple subscribers. Then we have replay subject. Now, replay subject does not have an initial value. We actually use replay subject in the take until pattern to unsubscribe because we don't want there to be a value in the stream until we want the component, until we want all the subscriptions in the component to shut down. Now, replay subject takes in one parameter, which is the number. If you do not pass a parameter into it, you will be caching every single value that comes through that stream. So that's something to think about if it's a very active stream. But what I usually do is pass in the number 1, which will then replay the last value to any subscriber. And again, it can have multiple subscribers. So we're going to set up a service. Now, I'm going to do something risky. We're going to lose our closed captioning here. But I'm going to switch over to VS Code. I actually have slides laid out for all of these, but I find it's a little bit hard to go through and actually not make it more confusing for people. So the first thing we're going to do is we're going to set up 2 services. We're going to have a filter service and we're going to have a product service. Now here's our component. Here's our component HTML. Let's see. I don't know if I need to make that bigger. Let me see. We'll try one bigger. Be bigger, you. It doesn't want to listen to me. Oh, I'm using the wrong key. That's right. Okay, so first thing I want to point out with these service, and this is true of both of them, they are both provided in root. That means it's a singleton service, which means that any component that imports these services as a dependency will get the same instance of this service, which means it will also get the same behavior subject. So we're also going to create a new behavior subject. So that's happening here. So this is for our filters. You provide a type to your behavior subject. And then again, we have to provide an initial value. Now, the reason I want this to have an initial value is because I'm going to be using this with combine latest operator. And if that operator will not actually let a value come through until there's a value in each stream, right? So all the streams it's combining. So we want this to have an initial value, even if it's empty. All right, so we've got our product filters, and I want you to notice that it is private, right? The only code that should have access to this subject is the service itself. And the reason we do that, here I've got a slide about that. There we go. Why is it private? Only the service should be able to call next on it. This will prevent accidental completion of the stream by one of the subscribers. And it will also centralize our logic, right? So we can provide a public API for components to interact with this subject, but only the service really knows how to do it. So kind of think of it like getters or setters or something in Java. Okay. So we're going to have our stream. Now we need to get some data into it. So let's see, down here in our constructor, we're actually going to provide our product API service. That's where I'm getting my products from. And I'm going to actually do a little work on them, but I'm not going to explain that. And then I'm going to, once I get the value out, this is where I'm going to subscribe. And this is where I'm going to call next on my observable. All right, so this is going to provide that first value from the API to the subscription. So if this is an HTTP request in Angular, this would actually complete on its own. So it would only get one value. All right. Now, the next thing we need to do is provide this into our components, right? So we do that by using the as observable property on the subject. So I'm going to take the I'm going to create a read-only observable property that's available. It's a public property, and I'm going to expose the subject using as observable. And then I'm going to actually, so I'm going to explain the rest of this code here in a second. And then I need to create a public API for my components to be able to call next to push more filters into this filter stream. So this is the public API of this service that allows you to call next on that subject. All right, so then the meat and potatoes of this thing, boop, boop, boop. This is where I need my thing to remind me where I'm at. But okay, so if we want to create a map of filters, so this one is actually when we pass in a selected filter. So when we call next down here, sorry, I'm flipping around a lot. So we're going to call next on our selected filter. All right, so what's subscribing to selected filters? So this is our selected filter. So when next comes in, it's going to hit this scan operator. So what the scan operator does, it's kind of like mini state management. It works like the JavaScript reduce array or reduce the JavaScript array reduce method. And basically it has an accumulator. So if there is nothing selected, if there's nothing there, it's going to return just the accelerator. If there's something that is selected, this is how we're going to toggle the selected property of our filter. And then we're going to return an array of filters here. So that's what this one is doing. I need to go back on my map here for a second. So we're going to also set up our product service. So let's get our products. We're going to do the same thing. Again, we have a singleton service. We're going to create a products subject that will hold the products. We're going to subscribe to that in our constructor. I think this is where I was supposed to start. So I got a little off the rails. I knew I would do that. So this is where we're going to push our products into our products subject, our products stream. And then this is how we are exposing them to the API or to the component. So we've got our filtered products observable. We've exposed that with the observable property. This is where we're using combined latest with. That is why I actually want there to be an initial value for this selected filters observable. Because if there was nothing here, this wouldn't emit a value. So since there's nothing, it's like, okay, is there anything in the selected array? If there's not, just return all the products. And if there's anything in there, we're going to filter out and only return the products that have the same product type. Okay. And then over here is where we combine them. So we've got our, this is where we're providing our filtered products. This is where we get our product filters from. Okay. I do have this code online. I will give you a link to that so you can kind of poke around at it yourself. So, because I know it's a little confusing. But then our component now looks like this. We have a products property, and it's an observable property that's set to the observable property on our product service, right? Our filtered products. So we've pulled in a dependency for that service. Same thing for our product type filters. And then we have a method that knows the public API method on our product type filters to be able to change our filters. So it's got the streams of what it needs to display, and it's got its way of saying, hey, my filter changed, right? So now let's look at the component HTML to see what that looks like. All right, so up in here, we've got our subscription somewhere. Here we go. Here's our products. So we're going to subscribe to them using the async pipe. Now, the reason we're using the async pipe is because when we pull this products observable in, this is an observable. Remember, observables are lazy, so they don't actually get executed until we subscribe to them. The async pipe handles subscribing to your observables for you, and it will also handle unsubscribing when the component destroys. As bonus points, it also will prepare your component for on-push change detection. It does not turn on-push change detection on, but what it does is that anytime a new value comes into the stream, it will mark your component for check, which will trigger change detection to run on your component. So if you do turn on-push change detection on your component, it'll have that already hooked up for you, so you don't have to remember to manage your asynchronous returns in your on-push change detection. And then up here for our filters, we've done the same thing. We've also used the async pipe, again, that subscribes and unsubscribes for us. And then it also prepares our component should we choose to turn on push change detection. Now you can see here, when we click on one of the checkboxes, it's going to send the element that was selected to this change filter selection method. So that's going to go over here. That's going to invoke this method here on the product filter service. Then that's going to emit the next value into the selected filter stream up here, which means that it's going to run the scan operator again. It's going to return a new array of selected filters, right? So this thing is only collecting the value of the selected filter. So it'll just be an array of strings. And then when this thing emits a new value, it's going to push a value into this stream here. So it's going to take the product type filters here and the selected filters, and it's going to go through the filters that we got from the API. That's what's in this observable here. And it's going to then set the is selected property. All right. So when the is selected property changes, so when we get a new value in here, this is selected property changes, which means a new value is emitted from this stream here. So we go back to our component at this point. So we've got this is listening. So then over here in our template where we asynchronously subscribe to that, so that subscription is still left open, which means this template's going to get marked for check. When change detection runs again, we're going to get an update, and we'll get the checkbox will display as checked. Now, when we get a new filter in, we go over to our products service. I'm just going to close this one for now. So this is we're using the combine latest with here. So we'll get a new filter. We'll get that new, that string array of filters. So we'll have our products from the API. We'll get a new value for the filter. So this time it's going to come in, and the selected is not going to be empty. So it's going to go through this logic, and it's going to return a new list of products. So it will automatically, we've got it connected to the stream here. It will automatically update this, and it'll automatically add and remove products from our table. So let's see this in action. This is the exciting part. Oh yeah, it totally works, right? So, so this is what we want. So I'm going to go back to my slides at this point. Let's see, hopefully it'll pick up where we left off. And all right, hold on, I'm getting there. So these are all, if I've lost you, I do have these in my slides. And we're getting there. I swear. There it is. Woo! We checked that in the browser, right? So our final component is less than 30 lines of code. It knows how to get the data that it wants. It's not pulling in data it doesn't need. It's not pulling in data it has to manage. And it knows how to say, hey, my filter was selected, right? And then we have two services. These services can be shared in other components. So all this code is reusable in other components. So any component that needs products or the ability to filter those products can do that. And these services are a lot easier to test and refactor than that 1,500 line code component. So there's a lot more to learn about reactive programming and state management, and you're in the right place. In fact, hopefully you caught some of the earlier episodes of the podcast or of the conference. I'm stuck in episode brain, but we had those. So look for those. If you missed those this morning, those recordings will be out at some point because Adia is amazing and will provide those for us. And then I also have some additional links for you here. And since you're like, Lara, I can't click on any of these links, I will also give you a link to my slide deck, which I will also put in the chat. So that is all I have for you today. I hope I uh, didn't go too fast. I do want to point out in my link, there is a link to the GitHub repo that has this silly little app in it for you. So,